Welcome to Center of Math's Unusual Properties in Math. Today we're going to give two examples, one of a sequence of functions, differential sequence of functions which converge uniformly to zero and whose derivatives diverge everywhere. And we're also going to give an example of a sequence whose limit of their derivatives does not equal the derivative over their limits. So first, a sequence of differentiable functions who converge uniformly to zero, whose sequence of derivatives diverges everywhere. So we're going to take our sequence f of n equals f of n of x equals sine nx over root n. So sine is always going to be between -1 and 1. Root n is going to infinity. And so clearly, we take n big enough, our function everywhere will be less than some epsilon. So this converges uniformly to 0. Fn prime equals root n cosine nx. And so root n is going to infinity. Cosine nx can get as small as we want, but we're going to show that no matter how large n is, we can always find a larger n such that the absolute value of cosine nx is going to be greater than 1/2. And so Fn prime will not converge at any given x. So to do this, assume cosine nx is less than 1/2, and cosine 2nx is, which by common identity is 2 cosine squared nx minus 1, which if absolute value cosine nx is less than 1/2, then cosine squared nx is less than 1/4. And so this will be less than -1/2. And so the absolute value of cosine 2nx will be greater than 1/2. And so we found our n, which will just be 2n. And so Fn prime of x, which equals root n cosine nx, diverges at any given x, because cosine nx does not approach 0. So an example of a sequence of functions such that the limit of the derivatives does not equal the derivative of the limit. So we're going to take f of n of x equals x over 1 plus n squared x squared. So as n goes to infinity, if x equals 0, then it's 0. If x does not equal 0, 1 plus something that goes to infinity over some constant x. That also approaches 0. So Fn of x as n goes to infinity equals 0 for all x on the closed interval -1, 1. The derivative Fn prime of x is 1 minus n squared x squared over 1 plus n squared x squared squared. So if x equals 0, that's 1 over 1. That's just 0. If x does not equal 0, then the term on the bottom includes n to the fourth. On the top is just n squared. And so the bottom term will dominate, and this will all go to 0. So limit as n goes to infinity of Fn prime of x equals 0 for x not equal 0, and 1 for x equals 0. And so note the derivative for the limit of Fn of x is just 0 everywhere. But this is not 0 everywhere. It's 1 at x equals 0. And so these two do not match. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. And if you like this video and you like this playlist, please check out our other Center of Math playlists. Thank you.